Ever wonder who keeps the world spinning? Literally.
You mean, like, not the planet itself?
Exactly. I'm talking about all the massive machinery, the turbines, the compressors, the giant engines, all that.
Ah, you mean the stuff that actually keeps the lights on.
Exactly. And that's what we're diving into today.
Mhm.
Rotating equipment mechanics.
And it's not just about tightening bolts, right? These are the folks making sure your airplanes stay up in the air.
And your factories are humming along.
All that good stuff. It's a pretty vital job when you think about it.
Absolutely. So today we're going deep into their world. And I know some people might think, mechanic, isn't that just like a mechanic?
Yeah, but it's way more than that, especially these days. The technology they're dealing with now is incredible.
It's changing faster than a turbine blade during a speed test, that's for sure.
That's a good way to put it. Think about it. These mechanics work on everything from power plants to oil rigs, even giant ships.
Talk about a variety of workplaces.
Right. And each one has its own unique challenges.
And let's be real, these aren't exactly cushy office jobs we're talking about here.
Definitely not. Imagine squeezing into a tiny space inside a wind turbine.
Hundreds of feet in the air.
Or maybe troubleshooting a pump on an oil rig in the middle of a storm.
Yeah, not for the faint of heart.
No kidding. It takes a certain kind of person to thrive in those environments, that's for sure.
So, what actually makes a rotating equipment mechanic in this day and age? Is it just raw strength and like knowing how to use a wrench?
Well, those definitely help.
Uh-huh.
But you're also dealing with high-pressure systems, complex diagnostics.
It's got to be more than just being handy.
Oh, absolutely.
Hmm.
You need a good head on your shoulders, too.
So like what? Math skills, engineering knowledge,
All of that. And increasingly, computer skills, too. You know what CAD software is.
3D modeling. Isn't that what like architects use?
Yep, same thing. Mechanics are using it to create virtual models of the equipment.
Hold on, they're using 3D modeling to fix giant machines.
Exactly. Especially when those machines are in a tight spot. Like, try squeezing into a turbine with a whole toolbox.
Makes sense when you put it like that.
Right. So they use these virtual models to plan out the repair job, even prefabricate parts off-site.
Wow, so they pretty much do virtual surgery on these machines before ever picking up a wrench.
It's kind of like that, yeah.
Yeah.
And it's becoming more and more common.
That's you sound.
So mechanics got to be adaptable, always learning.
It's not your granddad's mechanic job anymore, that's for sure.
Nope. It's this cool blend of old school mechanical skills and cutting edge tech.
Sounds like a pretty exciting career path to me.
Oh, it definitely is. And we haven't even gotten to the really cool stuff yet, like predictive maintenance.
Oh yeah, that's where they use data to predict problems before they even happen, right?
Exactly.
Okay, now that you mention it, that's something I wanted to ask you about.
So with predictive maintenance, we're talking sensors, right? Sensors everywhere.
Okay, I'm intrigued. Lay it on me. Where are we putting sensors?
Well, you can put them on pretty much any critical component, like bearings, gears, pumps, you name it.
So it's like giving the machines a constant checkup.
Exactly, 24/7 monitoring. But here's the real kicker. It's not just about collecting data, it's what you do with it.
Right, because a bunch of numbers isn't going to help anyone.
Exactly. This data gets fed into these sophisticated software programs, and they use all sorts of algorithms and machine learning to find patterns.
So it's like having a detective on the case, but for machines.
That's a great way to put it. Let me give you an example. Imagine you're monitoring vibration levels in a motor.
Okay, I'm picturing it. What am I looking for?
Well, even a small increase in vibration, one you might not even hear, the software can pick up on it.
Really? Even if it's like within acceptable limits.
Exactly. It can compare it to past data, even the manufacturer's specs. And it can tell if something's off, even if it's really subtle.
So you're spotting problems before they even really become problems. That's incredible.
That's the whole idea. It's about predicting failures before they happen.
Talk about a game changer. That's gotta save companies a ton of money.
Oh, absolutely. Downtime is expensive. So predictive maintenance is huge for reliability and cost savings, both.
Makes sense. But that also means mechanics need to know how to deal with all that data, right?
You got it. It's not enough to just be good with your hands anymore. You got to be a bit of a data analyst, too.
So we're talking part mechanic, part technician, part data scientist almost.
Pretty much. Those who can do it all, they're the ones in high demand these days.
So it's a challenging field, but it sounds like it comes with some pretty great perks, too. Like, what are some other pros and cons someone considering this career should be aware of?
Well, on the plus side, the job security is great.
That's always good to hear.
Right. Skilled mechanics are always needed. Plus, it's hands-on work, solving problems. There's a real sense of accomplishment.
I bet. bringing a giant machine back to life, that's got to feel good.
Oh yeah, it's definitely rewarding. But it's not always easy, of course.
Right, we talked about the work environments earlier. Not exactly a walk in the park.
Exactly.
Yeah.
It can be physically demanding, long hours. Sometimes you're on call, got to work weekends.
Those middle-of-the-night emergency calls, those can't be fun.
Yeah, those happen sometimes. And then there's the technology. It's always changing.
So you constantly got to be learning.
Yep. New tools, new techniques, you got to keep up. If you're not learning, you're falling behind.
So it's a challenging field, but it sounds like it's rewarding too. But how does someone even get started? I mean, there's so many paths you could take.
You're right, there's no single answer. It depends, your background, what you want to do, but a good place to start.
Yeah,
Math and science. Solid foundation there.
makes sense. So what, like trade schools, community colleges, those sorts of things?
Exactly. A lot of them have great programs, industrial maintenance, things like that. Give you the basics you need, both knowledge and hands-on.
So you're saying you don't necessarily need like a 4-year engineering degree to get into this field?
Not at all. Now, don't get me wrong, an engineering degree can be great, especially if you're thinking about the more, technical side of things.
It's like design work, research and development.
Exactly. But a lot of employers, they really care about experience
Mm-hmm.
and certifications.
Oh, yeah, the certifications. Those are important in this field, right?
Big time. You've got the Vibration Institute, the ASME. They offer some really valuable certifications.
And those show you've got specialized knowledge, right? Like more than just the basics.
Absolutely. Vibration analysis, lubrication, alignment.
Mm-hmm.
Those are things employers want.
So it's like a stamp of approval, tells them you know your stuff.
Exactly. And even if you're already working in the field, you can always specialize even more.
Oh, yeah, like becoming the go-to person for a specific type of equipment.
Exactly. Steam turbines, gas compressors, you name it.
Yeah.
Or even focus on a specific industry.
Right, like power generation, oil and gas, all that. So find your niche, become the expert. And that can lead to, like, management roles, right?
Mm-hmm.
Absolutely. Or even consulting. Sharing that expertise with different companies.
So many options. We've covered a lot of ground here, from, like, the actual nuts and bolts of fixing these machines to the high-tech stuff, the data, all that. It's a lot. And it's changing all the time, which makes me wonder, what's next for rotating equipment mechanics? What does the future hold?
That's the million-dollar question. If I had a crystal ball.
Yeah, no one can predict the future.
Right. But here's the thing. Technology is not slowing down. If anything, it's getting faster.
So mechanics need to keep up.
Exactly. We're already seeing this blend of mechanical, electrical, digital systems all in one package.
So you got to be comfortable with all of it.
Pretty much. The best mechanics, they're the ones who are adaptable, always learning new things.
So the future belongs to the curious, the ones who like a challenge.
Absolutely. Being able to solve tough problems, think on your feet, embrace the new tech, that's what's going to matter.
Well said. That's a great note to end on. A big thank you to our expert for this incredible deep dive. And to our listeners, we hope you enjoyed it as much as we did. Until next time, keep those gears turning